Hello, I am Shashank. I am currently third year PhD student at Robert Bosch Center for Cyberphysical Systems IISc, working under the guidance of Professor Gurunath Gurrala and Professor P.S. Shastri. And I am here to present on my work cyber physical modeling of power system network for vulnerability assessment. So basically, in the modern day context, the systems are no longer pure physical systems that were traditionally manually operated. So there is an element of communication and control that has come into play in pretty much every critical infrastructure that we see today. So be it IoT is one special case. So my research focuses on power system network, which is a critical infrastructure, and in fact it's not exaggeration to say that it is a driving infrastructure for many other critical infrastructures. So basically you need power to run things, power to uh, operate other devices, manage networks. So all the data centers, everything need the power, right? So it is very important to secure this critical infrastructure from the point of view of vulnerability assessment. So now basically a traditional power system which is integrated with communication technology forms a cyber physical network. So the power layer sends out sensor based data which is typically in terms of voltages and currents in the circuit to the communication layer, where based on the data some decisions are made and the commands are typically sent back to the physical layer to operate. So there are a few key challenges. So with the introduction of communication and networking devices, so there is a possibility of cyber attacks on the network. So which could lead to eventually a blackout in the worst possible case. It in fact leads to very high economic damage, equipment loss, and it in fact it affects livelihood. So can you imagine a blackout situation for about even for 6 hours, right? That is a big thing now, right? Imagine all your electronic devices stopped working, no power, right? It's very difficult to imagine at this point of time given the era that we live in. So there have been some blackouts in the past which have affected a lot of people. The 2012 North India blackout, 2015 Ukraine, 2021 Pakistan. So the 2015 Ukraine attack was a uh, classic case of a cyber attack based power system interruption. So where a malware was introduced into the network and it caused the power interruption by uh, launching a DDoS attack on again followed by a malware injection, so which caused all the control systems to kind of block their operation. So uh, the idea is to uh, have a detailed representation of such a cyber physical system for the power network first, and then do a vulnerability assessment. So as a part of this exercise, so the first thing is, so this is a typical physical layer network that I have considered with a few key components that are present in real substation, so which consist of circuit breaker, the current transformer, potential transformer. So this is a representation for one of the schemes in the real substation. So now on top of this layer there is a communication layer which actually controls these operations of breaker, and it takes data from the physical devices like current transformer, potential transformer, and then it issues commands to the physical devices. So this is a switched network which runs on typically Ethernet, and it has what we call as a combination of relays which are intelligent electronic devices, and it also perform protection functions. So suppose there is a uh, kind of any overcurrent or any physical layer contingency. So these devices come into act. Now, yeah, so typically this is how it is mapped. The physical layer along with the communication layer, there are some interactions happening, as you can see in the green section. So in our model, the physical layer is modeled based on a standard representation which is followed worldwide, which is IEC 61970 for the exchange of power system network data. The communication layer is modeled based on a realistic existing architecture which is present at the substation, and the cyber physical mapping captures their interdependencies in the network, and the overall cyber physical layer is modeled as a graph. So this is the overall framework where currently at this point of work I've been able to take an input data and build a Python based API to build the physical and cyber components, map them and build a cyber physical graph. The next steps in this work would be to pick up attack scenarios from a known vulnerability data and generate an attack graph and do a risk assessment for the entire framework. So this helps in knowing the weak points of the power system network, and thus a network hardening can be performed on it. Also it helps in planning and commissioning of the power system network. So as an acknowledgement, I would like to thank my advisors CNI for the initiative and support they provided me during this work for the current year, and also Power Grid Center of Excellence in Cybersecurity IASC for helping me with the substation configuration details. Thank you.